Right, good morning, good afternoon, or good evening, everybody. I'm going to use this video to talk about stratospheric ozone, which is covered by topic 6.2 in our current syllabus. Before I begin, it's worth pointing out that you should make sure you don't confuse stratospheric ozone, which exists obviously in the stratosphere, is often called the ozone layer, that you don't confuse it with tropospheric ozone, which is a type of pollution that exists in the troposphere. Which leads to problems of smog pollution. We'll look at tropospheric ozone separately. Before I show you the syllabus, I've listed the things we're going to talk about in order above my head, as you can see. So number one, we need to discuss the ozone or stratospheric ozone is important to us in the ozone layer because it absorbs ultraviolet radiation. It exists in an equilibrium in the stratosphere and prevents too much ultraviolet radiation reaching the surface and causing damage to plants and animals. Unfortunately, humans over the years developed certain products, certain pollutants that got into the stratosphere and started to break down stratospheric ozone or break down the ozone layer. They're known as ozone depleting substances. The most important of which you might have heard of are chlorofluorocarbons or CFCs. In the 1980s, when I was still fairly young, an ozone hole was discovered around the Antarctic. So there were global efforts to try to reduce the release of these ozone depleting substances to close the ozone hole. And to a great extent, that was a successful global effort. I'll explain that later and I'll explain why it was one of the more successful international efforts to reduce pollution. Okay, here's the syllabus. There's an awful lot of statements, but they're all statements of fact. I don't think I'll read them out word for word. I hope they're visible. And if they are, I think you should just pause the video and maybe read through them yourselves. But basically, it just repeats what I've already said in my key terms above my head. Number one, the ozone exists in an equilibrium under normal conditions. And number two, the ozone depleting substances affect that equilibrium and break down molecules of ozone. So they're not as effective anymore as absorbing ultraviolet radiation from the sun. Sorry. UV radiation, ultraviolet radiation, can cause damage to plants and animals, sometimes very severe damage at high concentrations. Methods have been put in place since the 1980s to either ban or regulate ozone depleting substances. And as a result, the ozone hole has largely closed, but it still does exist. One of the reasons for that is that certain ozone depleting substances like CFCs are very, very persistent in the stratosphere. And some of these CFC molecules that were released when I was a child in the 1980s, for example, still exist and are still breaking down ozone today. We need to talk about the role of the United Nations Environment Programme in coming up with global regulations for these ozone depleting substances. And the main thing that they were responsible for was something called the Montreal Program, or the Montreal Protocol, which developed from a meeting in Montreal, obviously, in 1987. And not as certain politicians today would have you believe, that it wasn't just something that affected the people of Montreal. It was a global meeting and a global protocol. Okay, so I'll move on fairly rapidly. I don't want to read through everything that's there, but you can in your own time if you like. We've seen this graphic before. This is an outline of the atmosphere. The troposphere is the first 10 kilometers or so of the atmosphere, and above the troposphere is the stratosphere. Within the stratosphere exists the ozone layer. Ozone is a molecule that exists of 3 oxygen atoms, so therefore we can write it as O3. written like that. Under normal conditions, it exists as these three atoms joined together, bonded together. And UV radiation, again under normal conditions, breaks ozone down, but it reforms in equilibrium. And as long as that equilibrium is unchanged, there's no problem. The ozone hole absorbs enough UV radiation to make it not a big threat to human life and animal life and plant life. Naturally, higher concentrations of UV radiation hit the Earth around the equator. Ozone is a greenhouse gas, you should be aware of that, but again, because it's in equilibrium under normal conditions, we don't say that it affects climate change. Ozone production and destruction is at equilibrium, but if we introduce ozone depleting substances, for example, chlorofluorocarbons, CFCs, which is the most well known, methyl bromide is another one, or nitrous oxides, we disrupt that equilibrium. Basically, these substances like CFCs, they bite away, they're a catalyst, they bite away ozone, they break away oxygen atoms from ozone molecules, and basically they release the oxygen atoms, which can then bond, instead of bonding back with the existing ozone molecules, they bond with separated oxygen atoms. And therefore, the ozone layer in certain places around the globe becomes thinner and thinner. And it's worth stating, without the ozone layer, UV radiation would destroy all life on Earth. So it's really, really important that we look after, well, as with all parts of our environment, but that we look after the ozone layer, the stratospheric ozone layer. Okay, you might recognize this guy whose picture I've put here. This is Mario Molina. He was Nobel Prize winner from Mexico, working at the University of UNAM in Mexico City. He was the person that discovered the role that CFCs, these molecules, play in breaking down ozone. And he was also instrumental in the discovery of the ozone hole in the early to mid 1980s. Unfortunately, he died at the end of 2020. Sad story. He wasn't that old, but he died of a heart attack last year as I'm recording this. So we can say that CFCs were or are useful molecules because they were produced in huge quantities as refrigerants in old fridges, and they were also used in spray cans as propellants, in pressurized cans like deodorants, things like that. Unfortunately, or I could say fortunately, Mario Molina discovered the role that they were playing in breaking down the ozone layer. And the ozone hole was discovered and first reported by the British Antarctic Survey in 1987. It was found later, moving through the 1980s into 1990s, that it actually it grew in size and then shrank in size seasonally. It exists basically over the whole of Antarctica. I don't know if you can see on the map, but if you look carefully, you might be able to see the outline of Antarctica there. But the ozone layer thinned in around the Earth in general. It was particularly bad around the Antarctic because that's where winds pushed these ozone depleting substances and where the effect was greatest on the ozone layer. There were effects in Australia, especially, and I'll talk about that a little bit later, I think. Okay, and I've said here, another reason why it occurred over the Antarctic was because ice crystals in the atmosphere provided catalytic surfaces to make the effect of ozone depleting surfaces worse. But we can thank Mario Molina for his discovery, and without his work, certainly we could say that the ozone layer would be in a much worse state today than it actually is. Okay, the effects of UV. One effect is obvious if you spend much time on the beach. This guy is suffering from very severe sunburn from overexposure to ultraviolet light, or specifically ultraviolet B light. So effects on humans, other animals, effects on the skin, severe sunburns perhaps, certainly increase in skin cancers. That's an effect of being hit by too much UV radiation. Effects on the immune system, Damage to the eyes, certainly, and an increase in the rate of cataracts. The effects can be acute or chronic. That means that if you're exposed to high levels of UV but over a short time, it's possible for the body to recover. Same with animals. But with chronic effects, when animals and humans can't escape from this increased concentration of UV light, the effects can be irreversible and very damaging. There is some possibility, or some studies have shown, that maybe high levels of UV affect vaccinations or the success of vaccination programs. There's evidence that they've affected fish stocks in the southern hemisphere, and certainly big falls in frog populations. Because of the nature of the skin of frogs, they're very, very susceptible to damage from ultraviolet radiation. In Australia, as I mentioned, there were certainly increases in levels of skin cancers, particularly in children. And in the 1980s and 1990s, there was a big effort by the Australian government to educate people to use sun cream, to always cover the body, and to use hats. It was called the Slip, Slap, Slop program. I believe it was slip on a t-shirt, slap on a hat, slop on some sun cream. Okay, in terms of plants, certain studies have shown that yields of crops have been reduced by being exposed to high levels of ultraviolet radiation. But there are programs in operation to try to look for genetically modified crops that can survive that. And one other thing that's worth noting is that there's certainly a decrease in yield in the southern hemisphere of phytoplankton, which are plant productivity in not only on land but also in the sea. Okay, and then finally, to finish, just my final point that you can see above my head is efforts to regulate ozone depleting substances, and specifically CFCs. So around the world, CFCs have largely, but not totally, been discontinued as propellants. Largely, they've been banned, certainly in MEDCs, as refrigerants, but they're still used in some LEDCs because they're produced so cheaply, and in some countries it's preferable to take the risk of using CFCs but still allow people access to refrigerants for their foods in terms of public health. In a lot of MEDCs, programs are put in place to ban old fridges being dumped, and if you should be responsible in how you recycle your old fridges, and you should take them to a recycling centre where old CFCs can be pumped out and not released into the atmosphere. It's less of a problem these days because most fridges these days don't, unless they're very old, don't use CFCs as a refrigerant. Methyl bromide, I mentioned before, it's a insecticide and a fire retardant material. It was a very useful material, but it was largely phased out in MEDCs in the mid-2000s. However, it is still used in a lot of countries, certainly in a lot of LEDCs, because it's still a useful and cheap material, not only as an insecticide but also as a fire retardant material. And then my final slide, I hope I've not gone too long. The syllabus mentions the work of UNEP, the United Nations Environment Programme, and UNEP was instrumental or responsible for bringing together governments from around the world in 1987 for the Montreal Protocol. And that led, certainly by the early 2000s, to bans of CFCs in MEDCs, and they're phasing out in other countries as well in LEDCs. It will take a little while longer for them to be banned completely. But in the meantime, it's been obvious from photographs and work on the ozone hole that the ozone hole is shrinking and the ozone layer is recovering. For those reasons, the Montreal Programme is seen as one of the most successful United Nations protocols ever put in place. There was no real dissent. and actions were taken pretty much instantaneously to try to bring down the use of these ozone depleting substances, and an effect was seen within a few years on the ozone layer itself. There's a few reasons for that, I think. One is there were only a few materials that had to really be looked at and banned. It was possible to find alternatives that worked pretty much just as well as the ozone depleting substances that were banned. With one exception, I would say CFCs were replaced by HCFCs, or hydrochlorofluorocarbons, and HCFCs are still quite a potent greenhouse gas if they're released into the atmosphere. So you could argue we swap one problem for another problem, but as long as CFCs and HCFCs are disposed of and recycled responsibly, they don't really have to enter the atmosphere. Another reason was that the manufacturers of CFCs, as well as having alternatives, possibly they weren't as powerful as some other lobbies, like the oil lobby is, in terms of looking at greenhouse gases. So they didn't really have a big voice or a big objection to what was put in place by the Montreal Protocol. But just to finish, I'll just repeat what I said before, that CFCs especially are very, very persistent in the environment, one of the most persistent human-made chemicals. And like I said before, some CFCs that were put into the atmosphere when I was a child, maybe some CFCs that I put into the atmosphere by my deodorant in the 1980s are still hanging around in the stratosphere and still breaking down ozone today. And that's something to take into consideration with pollution management, that some pollutants don't disappear overnight. They can stay around for years and years, or even decades. It seems, well, according to the work put in place by the Montreal Protocol, there should be total regulation and total bans in terms of CFCs in place by the year 2030. Okay, I hope that was helpful. It's a fairly concise topic, despite my usual rambling. I hope it made sense. I will speak to you in our class this week. All right, take care, everybody, and goodbye.